So good morning, everyone. Thank you for taking a few minutes out of your day to join us for a presentation. Today's presentation will be on Java test code coverage for within Web3 Message Broker or IIB. Just if you do have any problems hearing me, or if I'm not speaking clearly enough or loud enough, please let me know in the chat window, and I'll speak a bit clearer. And if I need to slow down, please let me know too. So just got a quick agenda up on the screen. So what we're trying to do is we're just going to discuss why we are interested in having code coverage and why we're interested in having code coverage in Java. We'll just do a quick demonstration of the code coverage running and what sort of output you'll see on the screen. We can then talk about a little bit around the use cases of how you might be using this in your everyday work to improve your code quality. And lastly, we'll just quickly go through how it's set up and how it fits within the process. So first thing, code coverage. So why code coverage in Sonar? Because Sonar is a convenient tool for managing and reporting code coverage. It's not the only tool. If you come from the Java world, Copature and Emma, and there's a few other plugins like that into the build process, allow you to produce HTML pages and coverage reports. Sonar is useful in that it brings all those coverage reports, metrics and issues and violations and all those sorts of available pieces of information into one dashboard to help you to look at the quality of your code and see how and where you can improve it. So getting back to why we're interested in code coverage in the first place. So code coverage allows us to measure how much testing or how valuable our testing effort in our regression and test suites are. So that allows us to get a measure of how much of our logic and how much of our business logic has been tested, where we might be deficient in testing, and where we might want to fill those gaps. With the intention that the more of our code that we're testing in a non-production environment, where it's cheap and easy to fix bugs, the fewer issues we'll have when we get to production. The fewer defects we'll have, the more scenarios we will have tested. Hence, the happier our customers will be, and the more stable our system and environment will be, which leads to improved code quality, improved delivery. Means you're more likely to be building correct solution if you're developing test cases and measuring the coverage of those test cases, because those test cases can help us discuss with our business users and our end users what the system's doing, whether it's matching their requirements. So that's why we are interested in test coverage. So code coverage in Java, there are a few tools out there already. I touched on a few of them, Copature and Emma, and for the .NET world, there's I think NUnit, and these report and these allow you to report test coverage within a separate segregated Java environment. So how these usually work is you set up a test case, and that test case runs, and then you would take those reports out and you present them and work out what's been tested and what hasn't been tested. With Broker, we've got a slightly different environment where we don't have the same ability to run standalone code in the environment in the same way we have the way of just running a Java main as part of a test. So to get around this, there's various ways of doing it. One is just set up the most ideal one is to do as much of your testing outside of the broker environment as you can. So in the case of Java, this is quite easy. So what you would look to do within your Java code that you're running within Broker, you'd design your code in such a way that so as much of your business logic is executable outside of Broker in a test environment. Running tests in a static environment. So what this would mean is you'd be able to develop and run tests within JUnit with a fairly high confidence level that what you've developed is going to be accurate and useful when you get into the Broker world. That being said, within Broker you can't cover everything. Well, that being said, outside of Broker you can't cover everything. You still need to deploy code into the Broker to make sure that it's executing as you're expecting, and that's where the code coverage running inside Broker comes from. So over the last couple of months, we've been developing code coverage for ESQL and XSL. So now we're just doing the same thing for Java. It runs in the similar sort of process. What we do is we take our code, we build a bar file, we deploy a bar file, and then we run our tests against that bar file. So what I'm just going to do here is I have a Sonar environment. I've got an Ant script, and essentially what my Ant script is going to deploy some. It's going to build some code, deploy some code. It's going to run some tests. So in this case here, what I'm doing is I'm running a combination of two Ant tasks, one called a HTTP test, and one called an MQ test. And what this means is we're deploying code into the broker, and then we're triggering that code using either a URL, a HTTP request node, or an MQ import node. So when broker receives a message, it executes some logic, and that's the logic that we're measuring our testing of. And so what we can just do here is we can see it's finishing. So just in the interest of making it go quick. So that's run the code. What that's done is taken our code, created a bar file, instrumented the bar file, deployed the bar file, run our tests, and recorded the coverage into something called a coverage XML file, which, just for interest, I will show you here. So we have here is the coverage XML file, and what this is a standard. It's a standard XML file that something called the generic code coverage plugin within Sonar reads and interprets. And so what we've done here is we've started off creating an empty one, and as our test case run, it fills up the covered and uncovered branches and covered and uncovered lines. So we can see here we've got ESQL, and we can see in here we've got an entry condition. So it looks like line 11 where we enter the SQL is being tested, and then we've got a number of different branches here, which some of them are tested and some are not. So the true basically indicates that the line has been executed as part of our test case. So at the moment you can see there ESQL, you can see message flows. In this case here is XSL. Unfortunately, at the moment the XSL isn't running at all in my broker. I'm not sure why. Then the one we're interested in today is the Java compute node. So we can see here we've got a Java compute node, and we're running. There's a couple of different paths through the Java compute node, and we're testing a couple of them, and some of them not being tested. So what we do then is we take this coverage report and we match it against our source code. So what I've got here, as we see here, it's got the coverage. I've produced a coverage report into the coverage directory. Then I've got the rest of my source code in the in my workspace. And what I'm going to do now is run the analysis report. And what this is doing is running the plugin, the message broker plugin over the source code. At the end of this, it's going to look for the because I've installed the generic code coverage plugin, it's going to look for a setting in the configuration file for Sonar, which is the generic code coverage report paths. It's going to try and find that file. If it finds that file, it's going to match the contents of that file. The contents of that file against files it finds in that directory. And what you can see here is if I just refresh the dashboard, we can see here that this analysis just run. I'll go into the quality, go to the QG later. We talk about use cases. And so now we see our analysis. So what this analysis is saying is I said we've matched up our code. Actually, I'll just go just in dashboard for a second. So what is now analysis is telling us is a few things. So we've got our issues, our duplications in our code coverage. So what we've done with our code coverage is It's flagged in red because what we've provided as part of our setup is what we call a quality gate. So what we're trying to do is reach a minimum level of code coverage before we want that code to say it's passed the quality check. So if we go into the code, we can see here it's got a summary of different pieces of information about our code, and then what we're interested in now at the moment, for the purpose of this presentation, is the coverage percentage. So what we can see here is the coverage. The code's covered 17%, and if we dive into the Java code, we can see the Java code is covered 80%. So I'm just going to dive into the Java code, into our two Java files. And now what we can see here is we're seeing the red and green arrows, and these are the standard Java checks that that Sonar incorporates into reporting for Java files. So your standard sort of find bugs in check style and PMD type reporting, which comes standard for Java running under Sonar. But then what we can see here is also these little green markers. So what we can see here is we've got these entry conditions, or particular points we're interested in what's happening with our code coverage. So in the case of this particular file, how we read it is we can see here that there's one condition, which is the entry condition into the method, which we can see is being covered. So it's what we're saying is this method is being invoked within this condition. Within the file, there's another condition based around a while condition. So what we have is this while loop, and what we're saying is that while loop is executed and the entry into the while loop is completed. So we've run what's inside the while loop. Further on down, we can see that there's an if-else condition, and what we can see is only one branch of the we can see one branch of the condition is covered, and not the other branch. And then we can also see now exception handler here. We see that only one exception handler is there's one path to the exception handler which hasn't been tested. So that's showing it's a fair bit of coverage. So we go back to our report. Our dashboard. We can see in our second file we can also see the same 4 coverage paths. So this is saying our test codes, tests are being covered. So now what we can do here is, just for the purpose of the demonstration, is if we look at the test cases being run, and if we remove one of our test cases, which we know triggers our Java code, what we're going to do is run our deployment and our test cases again. And we'll just remember what we had here. So we had entry condition here, these pieces of code. So now we're just running a few of our test cases, not all of our test cases. We run our analysis again. Now remember last time we had a test coverage of 17% and 80% for our Java code. And what we're now done now, we'll go back into our dashboard. We can now see that our coverage is sitting at 13.8%. So our coverage has dropped. So we've disabled one of our test cases because we decided we thought mine might not have been needed, or we couldn't get it working, so we've disabled it. And now when we go into coverage, so we'll just go into coverage again. So now when we go into our coverage, we can see that only 40% of our Java code's actually being tested, 40% of our Java paths are being tested or covered. So we can see here that our original file, or our first Java file, is still being covered through the various conditions. But now we see the second one, which is the one we just disabled. We can see here that it's actually not being executed. So we can see here that the method isn't being called. Neither is the while loop. Neither is the while loop entry condition on the while loop. Neither is the while loop entry condition, and the if else hasn't been executed either. So what we can see is we've dropped out. Our test coverage has dropped. So the similar sort of thing would happen if we introduce a new node or a new flow and we don't add a test case for it. We'd see our test coverage drop as with the introduction of new code. Does anyone have any questions just before I go into a bit more about the instrumentation process, and then talk about a little bit about how this would how you might look to use this minimum level? Okay, looks like there's no questions. We'll push on. So just a quick, I'll quickly show you what's involved in the ant script, just for interest. Then we'll talk about how we use it. And so what we can see here is that the coverage file has been updated with markers indicate the lines are not being covered. So what we have here is we have a fairly automated process. There's 2 steps to it at the moment. There's no reason it couldn't be set to 1. And the steps are we build a bar file. In this case here, just for speed and convenience, I'm actually manually building a bar file rather than using the IBM provided tools, just because it's a bit quicker. So we build our bar file and produce a project of bar file. We take that project bar file and we run what's called the instrumentation task, which is provided as part of the toolset that we provide as part of the plugin. That instrumentation path, that instrumentation task takes a number of parameters. It takes a directory of where it can work from. So essentially what it does is it unpacks the bar files required and does some work on those files and repackages the bar file. This gives us a clean working area, in which case to do that processing. The source code, now this is where this helps it match against the code in the bar file that you're just wanting to deploy or just build, and the code in your repository, or your code in the rest of your directories that needs to be matched up against what's there for Sonar. So we use this to match against the rest of the unprocessed code. So what we can do is we can report on code that's covered in the bar file, and then we can report on the code that's not covered outside the bar file. And this is important because you may have multiple bar files that you're using to build up your environment. So you may actually have one file. You may have 10 files in your project that you need to be tested, and each bar file's got 3 or 4 of them, which means they're all still tested. And we use that to identify which ones are and which ones aren't. The key coverage, and this is our way of handling multiple bar files. So if you've got 1 bar file, we just set that key coverage to no. If you've got 2, you'll you'd set the key coverage to no for the first bar file being instrumented, and the second and subsequent bar files you're set to yes. So your coverage file will be incrementally accumulated. The bar file is the bar file you're looking to instrument and deploy. Cover XSL, this just indicates that you're looking to do XSL coverage. Cover Java just indicates using Java coverage, and the Java node file name is just the jar file that of the message record code we need to include, so that we when we reassemble the instrumented classes, they tie together. It's just easier to provide or to use the IBM provided version than package our own, just so we don't get any inconsistencies with any versioning or any method calls or anything like that are available. And then the coverage file path is where it produces this coverage XML file. So after you've instrumented your bar file, you deploy it to your broker, and once you deploy it to broker, you start what we call the test listener. So the job of the test listener is to be invoked from the instrumentation process, so that it knows what lines in the coverage file it needs to update. So its job is to take the incoming messages back from the executing code in broker and match it against the coverage file, so as to know what's being covered. So what we do here is we start something called the listener. In parallel, we start the listener. Now this listener starts on the same port number that we configure in our instrumentation. So when we, might need to just mention that when we instrument the bar file, we can tell it what port number and URL to use. In this case, it's using default port, and the default port number and URL happens to be 9011 and localhost. So what we do there, we start the listener, and then once the listener has one path in the parallel is to start the listener, and the other path is to start running the tests. At the end of running the test, we call what's called the stopper, which tells it to finish so that the coverage file can be written, and then we can process the results. That says the test is made up of calling two different tasks. We've got a URL test ant task, which calls URL and just sends a bit of text, and the other one we use is an MQ test task, which we'll see here. Sends a text message, or sends a message from a file to a particular queue and channel on a queue manager to trigger the test, or to trigger the test. And the last step was run the analysis of the project, which brings in this coverage file. So that's the instrumentation process. Now we'll just while we've got a few more minutes, we'll just talk about some standard use cases. So I talked about these on the dashboard here. We've got this quality gate. So we've got a big red X here. And what we've done for this project is we configure what we call a quality gate and a quality profile. And what our quality profile for this project means for this project we're talking about here is we are interested in test coverage. So what we can do as part of the Sonar infrastructure, or the standard Sonar functionality, is we can set a warning and what we call a break for particular metrics about our project that the analysis comes across, or the analysis produces. In this case, we're talking about Java code coverage. So what we've set up here is we've set up a value for the minimum acceptable level of test code coverage that we want to accept. So what we've got here is we've got a warning here. So we've got a threshold to say when test case coverage is less than 40%, we're going to flag a warning. We're going to flag an issue on our issues dashboard. What we're going to do is then we can say at 30%, we're going to flag it as an error. Now what this means is when it flags as an error, there's two things that happens on your dashboard. It shows up with a big red dot to say it's one of the quality gates has failed. And there's no numerous ways of following the quality gate. And we'll just try it here. Jenkins running. There's numerous ways of failing the quality gate. We'll just try. We'll just try to do it here, but what you can do, and I just might need to set up. Okay, this is probably not going to be ideal for the demonstration, but what you can do within say your Jenkins is run your analysis, and then behind your analysis comes along something called the build breaker, which you may not be able to see. Now what the build breaker means is that when this quality gate fails, you can set up, or you can configure the quality gate to actually fail. So what we can say here is when we have, we'll just try here with issues. Coverage less than 40%. Okay, so I'm not exactly sure why this one isn't actually failing, but what we'd normally see is we had a different method, a different we'll add a different message. What we can see is if we have more than 5 critical issues, if we have more than 5 critical issues, we're going to flag it as a warning. If we have more than 10 critical issues, we're going to flag it as an error. So what we can do here, because we can see that in our project here, in our issues, we've got a whole bunch of issues. When we actually run the analysis again against this project, we'll actually have more issues recorded than what our quality gate will allow. And what we should see at the end of our build, what we're not seeing is it breaking. Let me just check something here. Apologies for this. So what we're expecting to see is the build to be flagged as broken. What we can actually do here is run our Jenkins job. We'll just run our Jenkins job here. And we should see our Jenkins job fail as well. So what I've got here is it's a slightly different project than what I'm demonstrating here, but essentially this one's actually pulling it from this Subversion repository and running a Jenkins job against it with the intention of demonstrating how you can go in a build cycle. You can have Jenkins triggered by a check-in event or in a periodic schedule. It would run, check out the code, run the static analysis, run potentially the test coverage, and process and publish those reports back. Now what we're seeing here is the execution has been fine, and for some reason the build is not breaking, which is a little bit embarrassing. So our demo there isn't breaking. So we'll just go back into our quality gates for a second. And we'll just add all projects to that. And what we'll do is we'll just run our report again. And we'll see if we can get our build breaking. We'll also run our Jenkins job again, and we'll just see if just build again. Okay, so what we'll do is We'll let it run one more. No, looks like I'm not going to be able to demonstrate the build breaking, so I'll just have to investigate why that's been disabled. But hopefully you can imagine the situation where once the build broker is picking up the correct percentage of coverage, which it appears to be doing, it's not breaking the Jenkins job. So we can see here that both these jobs have been said they're failing our quality gates. And once something's failed our quality gate, ideally our build process or our delivery process will actually stop. So if a deal rejects in a change but doesn't have enough test coverage, or it gets to reducing the overall test coverage by a significant amount, what we can do, or below the threshold, what we could do is when we check out the code, run the tests, we'll detect that condition, we'll send the developer an email, and then we'll actually fail to deploy that particular new version or new tag, depending on how you do it, to an environment. So what we can do is gets us part of our way down the path of being able to do our continuous integration and continuous deployment, where the combination of the sonar analysis and the test case coverage gives you those automatic quality gates of whether or not the code should be deployed. So it's just past the half hour which we scheduled in. So I will just give everyone just a minute to see if anyone has any questions. Otherwise, I will let everyone get along with their day. In the meantime, if you do have any questions, my name's Richard, and via our website you can contact us either via email, at richard@bettercodingtools.com, or via our website using the Contact Us page, which is on the right hand side. So it sounds like no one has any questions. So what I'll do is I'll jump off the line so everyone can get on with their day. I hope you have a good one, and if you do have anything you want to ask, please feel free to get in contact. Thank you for taking the time to join me for this presentation.